today we will continue from exercise question number 2.16, right? Heptane and octane from an ideal solution at 273 Kelvin. The vapor pressure of the two liquid components are 105.2 kilopascal and 46.8 kilopascal respectively. What will be the vapor pressure of a mixture of 26 gram of heptane and 35 gram of octane? Right here in the question we have to find out the total vapor pressure of mixture having 26 gram of heptane and 35 gram of octane. Right, in question also given the vapor pressure of heptane is P1 naught 105.2 kilopascal and vapor pressure of octane P2 naught equal to 46.8 kilopascal. Right, the mass of a heptane is 26 gram given and mass of octane is 35 gram given. Right, now we can find the molar mass of a heptane and octane, right? Because heptane having formula C7H16, right? You can calculate by CN H2N plus 2. तो हमें क्या मिलेगा? हेप्टेन C7H16. तो हमारा molecular mass हो जाएगा 100 gram per mole and molar mass of octane will be a 114 gram per mole. Right? Now mole of heptane equal to mass by molar mass. Replace both terms and you will get the moles of heptane. Same, mole of octane is equal to mass by molar mass. Replace both value and you will get the moles of octane. Now mole fraction of heptane equal to moles of heptane divided by total mole. We already find out the moles of heptane and also the moles of octane. Replace that value, you will get the mole fraction of heptane, which is 0.456. Same, mole fraction of octane, total we know that mole fraction of two solvent and solute will be a 1, right? So we can say that the mole fraction of octane equal to 1 minus mole fraction of heptane, right? Or you can find by this method also, moles of octane divided by total number of mole, both having the same answer. Right, now for the P total we want the pressure of octane, pressure of heptane. Right, P1 equal to mole fraction into P1 naught. We find out mole fraction and P1 naught is given. Replace both the value, you will find the P1. Right, pressure of heptane solution. Same, you will get the pressure of octane solution. Now combine these two and you will get the P total. Right, now next question 2.17. The vapor pressure of water is 12.3 kilopascal at 300 Kelvin. Calculate the vapor pressure of 1 molar solution of the non-volatile solute in it. Right, 1 molar solution is given and the vapor pressure of water is given and we have to find out the vapor pressure of vapor pressure of solution. In question we having 1 molar solution means 1 mole of solute is dissolved in 1000 gram of solvent and solvent is our water. So we can say that moles of solute is equal to 1 mole and moles of solvent equal to mass by molar mass. Mass is 1000 gram and molar mass is 18. So you will get the moles of solvent. Now mole fraction of solute is equal to moles of solute divided by total mole. Replace that values and you will get the answer. Moles of solute is equal to 0.0177. Now the water vapor pressure of water is given 12.3 kilopascal. Right, now by the using formula of lowering in vapor pressure, right, whenever we dissolve any non-volatile solute in any solvent, there is a decreasing in a vapor pressure. Right, there is a lowering in vapor pressure which is termed as P1 naught minus P1 divided by P1 naught equal to mole fraction of 2. Replace all value. Now cross multiply it and you will get the vapor pressure of solution 12.0823 kilopascal. Right, question number 2.18. calculate the mass of a non-volatile solute having a molar mass of 40 gram per mole, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%, right? Here we have to find out the mass of non-volatile solute, right? Here when we add this non-volatile solute of X mass having a molar mass 40 gram per mole, the vapor pressure of octane is decreased 80%. So we can suppose that if the vapor pressure of a pure solvent is 100 gram and it's lowering decreasing 80, so P1 equal to 80. We have to find out the mass of that solute, right? And molar mass of solute is 40 gram per mole is given. The mass of solvent is given 114 gram, and molar mass of solvent means octane is equal to 114 gram per mole. Now lowering vapor pressure equal to P1 naught minus P1 divided by P1 naught equal to mole fraction of solute. Mole fraction of solute, so we can say that mole fraction of solute equal to moles of solute divided by total mole. Here moles of solute is very less than to the moles of solvent, so we can neglect it. So we will get P1 naught minus P1 divided by P1 naught equal to N2 by N1. Now moles of solute equal to mass of solute divided by molar mass, and moles of solvent equal to mass of solvent divided by mass of solvent. Replace all the values which are given, so you will get the molar mass of solute, which is 8 gram, right? Now question number 2.19. A solution containing 30 gram of non-volatile solute exactly in 90 gram of water has a vapor pressure of 2.8 kilopascal at 298 Kelvin. Further 18 gram of water is then added to the solution and the new vapor pressure becomes 2.9 kilopascal at 298 Kelvin. Calculate first the molar mass of the solute and second vapor pressure of water at 298 Kelvin, right? Here we are adding 30 gram of non-volatile solute in a 90 gram of water, means water is our solvent, right, having a mass of 90 gram. When we add 30 gram in that 90 gram, the solution form which having a vapor pressure is 2.8 kilopascal, right? Further, if we add 18 gram of water in this solution, means that the total mass of solvent will be 90 plus 18. The solution having a vapor pressure 2.9 kilopascal, right? For this, we have to find out that non-volatile solute which are adding during the solution, in the solution, right? And we also have to find out the vapor pressure of pure water at 298 Kelvin, right? Means we have to find out P1 naught and M2, right? We use the vapor lowering vapor formula, which is P1 naught minus P1 divided by P1 naught is equal to X2. Replace the formula of mole fraction of X2, right? So you will get N2 by total number of moles. Now moles of solute is mass by molar mass. Mass is given, which is 30, so replace that value and we have to find out the molar mass. Here the moles of solute will be a mass of solute divided by molar mass of solute. We are using 90 gram of solvent, so our moles of solvent will be a 5 mole. Replace all the value, right, and simplify. First take LCM, right, and give separate division P1 naught, right. Then take this term to other side of equal. Then again take LCM, right. Then you will get final answer P1 naught divided by 2.8 equal to 5m2 plus 30 divided by 5m2. This is our equation number 1, right. Now we are adding 18 gram of water in this, means our solvent mass is 90 plus 18 and our moles of solvent will be a 108 by 18, it will be a 6 mole. And for this solution the vapor pressure is 2.9 kilopascal, right. Again we use this formula, same formula, and replace all the value. Simplify just step by step. You can see this and you will get the final P1 naught divided by 2.9 equal to 6 M2 plus 30 divided by 6 M2. This is our equation 2. Now divide equation 1 by 2. So you will get this. Take this term in the multiplication. So you will get this type of term. Now cancel out M2 and cross multiply terms. And then over the brackets you will get the molar mass of non-solvent will be a 20 gram per mole. Now replace this value to any equation. We are replacing this M2 value in equation number 1, right? You will get the pure water vapor pressure, which is 3.53 kilopascal, right? Now question number 2.20. A 5% solution by mass of cane sugar in water has freezing point of 271 Kelvin. Calculate the freezing point of 5% glucose in a water if freezing point of pure water is 273.15 Kelvin. Right here the freezing point of 5% cane sugar solution is given, which is 271 Kelvin, and freezing point of pure water is given, which is 273.15, right? And we have to find out the freezing point for the 5% glucose solution, right? We can find out the depression in freezing point, which is TF naught minus TF. Replace that value, you will get delta TF is equal to 2.15 Kelvin, right? Now we having 5% solution of sugar, means we are dissolving 5 gram of sugar in 100 gram of solution, right? So mass of solid will be 5 and mass of solvent will be 95, because mass of solution is 100, so mass of solvent will be 95. Our solute is the sugar, which is which having formula C12H22O11. So you will get the molar mass of sugar will be 342 gram per mole. Now we have formula for the depression in freezing point is delta TF is equal to KF into M. Now M is our molality. Molality means mass of solute divided by molar mass of solute into mass of solvent. If mass of solvent is in gram, then we have to multiply by 1000, right? Now replace all the terms. So you will get the KF, which is depression freezing constant, right? So you will get KF is equal to 13.99 Kelvin kilogram per mole. Now we have to find out delta TF for this the 5% glucose solution. So 5% glucose solution means the 5 gram of glucose is dissolved in 100 gram of solution. So mass of solute is 5 gram and mass of solvent will be a 95 gram. Molar mass of glucose, the formula of glucose is C6H12O6. So mass of glucose, molar mass of glucose is 180 gram per mole. Now again use this formula, delta TF is equal to KF into M, where M is a molality and molality equal to mass of solute divided by molar mass of solute into mass of solvent, and you will get the depression in freezing will be a 4.09 Kelvin for the 5% glucose solution, right?